Yes. First of all, go through the question. This is 101 question. First question. The current equation of, yes, okay. Current equation of PN junction diode is, this is one of these easy question, direct question, right? So everyone knows the answer of this one. The current equation of PN junction diode is I naught into e to the power of V by eta Vt minus 1, right? So I naught into e to the power of eta Vt by, yeah, so I naught into e to the power of V by eta Vt minus 1, only this one satisfies, remaining all are wrong. So this is one of the easiest and simple question, direct question, right? So the answer is option 2 correct. Yeah, another question, question number 102. When the reverse bias is decreased, the depletion region narrows, right? Decreasing the separation between the p-type and n-type regions, its capacitance is, so capacitance general formula is epsilon A by D, right? Epsilon A by D, D explains the distance, between the two semiconductors like p-type and n-type. That means the width of the depletion region. So we can write like this now, capacitance is equal to epsilon A by omega. So omega is nothing but here width of the depletion region, right? So if it is decreases, if the W is decreases, then the capacitance is increases, because both are inversely proportional, right? So we can write now, here the depletion region narrows, so the depletion region is decreases, capacitance is increases. So according to the given question, option 2 correct, one of the simple question, direct question, right? Just please take this. Yeah, another question from this ADC subject. This is question number 103. The feedback topology for which input impedance and output impedance increase. See, in gunshot bits and test papers, like a special test, in grand test, in every test one question is given on this concept: voltage series, voltage shunt, current series, current shunt, right? So there I have explained one table also. So within the table, from the table we can write the answer directly. Otherwise just go through the question. Here, which input impedance, output impedance will increase? So both has to increase, right? To increase the input impedance, we required series connection, right? And to increase the output impedance, here also we required series connection. Series connection means which type of sampler? Current sampler. So current sampler increases the output impedance, series mixer increases the input impedance. So from that we can write now the answer is current series feedback amplifier. So then go through the options here. So option 3 correct, current series feedback amplifier. This current sampler increases the output impedance, right? And series mixer increases the input impedance. So according to the given question, we have to increase both input impedance and output impedance. So according to the given question, current series is the correct answer. This is also one of the repeated question, right? So option 3 correct. Please take this. Yeah, one more question now. The average value of the following full wave rectifier output voltage. So this is the full wave rectifier output voltage. This voltage is the maximum voltage, right? So we have to find out the average value. So what is the standard formula for the average value of a full wave rectifier? That is 2 Vm by pi, right? So 2 into Vm. Vm value is how much here? It's given 15 volts. So substitute that value here, 15, right? So that is pi. Then this will give 30 by pi value is approximately, we can write 3.142. So if you solve this, approximately it gives the 9 point something. So according to the given question, 9.55 is the correct answer. This is also direct question, simple question. Already we have discussed these equations in gunshot bits and in special test and in pre-ESET exam. So there I have explained this type of question: average value, RMS value, efficiency, ripple factor. Now from that one direct question is there, that is average, right? So answer is 9.55. Yeah, this is also one of the repeated question. Stability factor of the transistor biasing circuit, that is standard formula 1 plus beta by 1 minus beta into dIB by dIC. So one of the standard equation, this one here, 1 plus beta by 1 minus beta into dIB by dIC. So directly we can select the option 2. So option 2 correct. Yes. Yeah, this is also one of the simple question, easy question, direct question. It comes under double level clipper. It comes under double level clipper. See, input signal is a sinusoidal signal which is defined up to 10 volts and negative maximum is minus 10 volts. So the sinusoidal signal is varies in between 10 to minus 10, right? And that is connected to this circuit now. So this circuit is a diode 1. So let us assume here diode 1. I am assuming here this is a anode and a cathode, right? So VA1. Right, VA1 voltage, and this one is I am writing here cathode, so VA, VK, VK2. So here the input voltage, so input voltage is greater than the VA1, okay, greater than this one voltage. So here VK1, this is already connected, which how many volts here? 5 volts is connected, right? So 5 volts is connected. If the anode voltage, so this input voltage is greater than the VK1 now. Let us write VK1, that is we can write like this, input voltage is greater than the 5 volts because your cathode terminal is connected to the plus 5 volts. If the input voltage is greater than the 5 volts, then the diode 1 operates in forward bias state, right? If it is forward bias state, this acts as short circuit. If it is short circuited, output voltage is equal to how much here? 5 volts only, because in that time period that diode D2 is acts as reverse bias. So D1 is forward bias and D2 reverse biased. So it acts as open circuit, but this one is short circuited. Then finally output voltage gives the 5 volts if the input voltage is greater than the 5 volts. See here greater than the 5.7. So why it's 5.7? Because here we have to assume the diode voltage is 0.7 volts, right? So 5 volts plus 0.7, that becomes a 5.7. So let us write here 5.7 volts. If the input voltage is greater than the 5.7 volts, then the diode 1 operates in forward bias state, diode 2 D2 operates in reverse bias state, then the V0 voltage is 5 volts. So V0 voltage is 5.7 because we have to add that point also, 5.7 volts. See this one here now, right? And whenever the input voltage, so now one more condition I am writing now, the input voltage, see this diode D2 connected to the cathode terminal, right? If the input voltage is less than the VK2, so VK2 means here it is connected to which voltage here? 5 volts, and the diode voltage is 0.7 voltage. That is, we can write like this, input voltage is less than the minus 5.7 volts, D2 operates in forward bias and D1 operates in reverse bias, because D1 operates in forward bias with this condition only, right? Other than this condition, D1 operates in reverse bias. So D1 operates in reverse bias, then the output voltage is how much? Minus 5.7 also this voltage here, right? And if the input voltage is in between these two levels, if the input voltage is less than the 5.7 volts and greater than the minus 5.7 volts, so in this case both D1 and D2 operates in reverse bias. So both are operates in reverse bias, means these two are acts as open circuit, then the output voltage is equal to input voltage. So output voltage is equal to input voltage. So within this period the output and input both are same, so that's why it is acts as double level clipper. This is one of the standard circuit, just we have to follow the voltage levels, that's it, right? So double level clipper, so here it is given like this. So which option now? Option 1 correct. And see option 2 also there, but here plus 5 volts minus 5 volts is given, right? And these two are not possible, so we can select this one. If we take the diodes are ideal diodes, then we can take this one, but here clearly mentioned voltages and resistors are mentioned, so that's why we have to take a 5.7 and minus 5.7 is the correct answer, because within the diagram, within the question, ideal diodes are not mentioned, so we have to consider the practical conditions only. So diode cut-in voltage, silicon is given, right? So silicon diode cut-in voltage is how much? 0.7 volts. So clearly mentioned, silicon means the cut-in voltage we have to take 0.7 volt. From that we have to select only this option. So option 1 correct according to the given question, right? Please take this. Yes, this is another one of the standard question and repeated question. So question number 107, the circuit shown in the following figure is, see, whenever the diode and capacitor, these two are connected in series, then the circuit acts as a clamper circuit. So rectifier is not possible, clipper is not possible. Now here the diode is given towards the downward side, it acts as a negative clamper. See, just I am taking the input signal is like this, sinusoidal signal. Right. If it is connected to this circuit, then this circuit shifts the complete signal towards the negative axis side. Right. Towards the negative axis side means now the expected signal should be like this. Right. So the complete signal shifted towards the negative side. So then it acts as negative clamper. So negative clamper is the correct answer. This one wrong. So in objections we can give this objection here, because here positive clamper is given according to the given answer. So that is wrong. This circuit is acts as negative clamper, and we can remember one simple method here, shortcut method. If the diode is downward direction, then the complete signal shifted towards the down, and if it is upward direction, we can shift towards the upward direction. Like that also we can write. But according to the operation, see, first of all, this diode initially during this cycle, diode operates in forward bias. If the diode is in forward bias, then the capacitor charges. So it charges up to maximum level Vm, right? And whenever this input signal enters at this point here, from this point onwards, this diode operates in reverse bias. So it acts as open circuit. So if it is open circuited, then the output voltage is equal to, we have to write like this, input voltage plus capacitor voltage, right? So input voltage is Vm and capacitor voltage is also Vm. So then it becomes now how much here? 2 Vm. So after this voltage becomes here 2 Vm. So that's why from here onwards it goes towards the downward direction only, right? So this circuit is acts as a minus 2 Vm. So the direction is negative direction. So minus 2 Vm we have to take. So the complete signal is shifted towards the downward direction. This circuit acts as a negative clamper, but positive clamper is given. So that is wrong. So according to the given answers are option 3 correct, right? Please take this. Yes, one more question. A GNR diode exhibits the following characteristics shown in the figure. So just observe the given characteristics here. Delta Vz is given here. Delta Vz, that means change in voltage, right? Delta Vz is given. Delta Vz is how much? 100 millivolts. And the current axis also given. See, this delta Vz is given from this point to this point. Then we have to take delta I here. Delta I, change in current, right? Change in current I am taking now. So subtraction of these two, that is minus 20 milli minus of minus 40 milli, right? That becomes how much here? 20 milliamps. So change in current is 20 milliamps and change in voltage is 100 millivolts. Then we want here GNR impedance. GNR impedance. So GNR impedance Rz is equal to change in voltage, GNR voltage by change in GNR current. According to the given problem, change in voltage is there 100 milli by change in current, how much we got here? 20 milli. Substitute that part here, 20 milli. Milli get cancels. So 0 0 now, which gives the how much here? 5. Okay. So GNR resistance is how much here? 5 ohms. So according to the given question, option 4 correct, right? Let's take this. Yes. Another question. This one is also one of the simple and easiest question, and we have discussed these questions in gunshot bits, right, and special test, and in preset also I have explained the same analysis, right? Ideal value efficiency of the class B power amplifier, that is 78.5%, right? Class A power amplifier is maximum we can take 50%. For class B 78.5%, for class AB in between 50 to 78.5%, and for class C we can take 90, high efficiency, that is 90 or 100. So this is also one of the repeated question. Already we have discussed this question in gunshot bits, right? So please take this. Yeah, this one is also one of the repeated question and simple question. Already I explained the same question, not same question, similar question in gunshot bits, like a monostable multivibrator requires how many trigger signals, astable multivibrator requires how many trigger signals. So now it is given in terms of matching question, list 1 and list 2. So monostable requires one stable state, So monostable multivibrator has one stable state, that's why the name is monostable, right? It requires one trigger signal. And unstable multivibrator, no stable state. So we can select this one now, no stable state, right? And bistable multivibrator requires how many stable state? 2 stable states. So directly we can select that one now. The remaining one is go through this one here. Free running multivibrator, alternative high and low output. So free running means without any giving signals, so directly which gives the high low signals like this. So alternative high and low output. So we have to select which option now? A2, right? A2, B1 and C4 and D3, right? So then go through the options. Yeah, it's given reverse order. 2A, 1B, C4 and 3D. So this option is the correct answer. So this is also one of the simple question, right? Please take this. Yes, another in a CE amplifier the collector resistance is 6 kilo ohms and load resistance is 3 kilo ohms is given. Then we want AC load resistance. So AC load resistance, see given data is collector resistance is 6 kilo, right, and load resistance is 3 kilo. Then the output resistance or AC resistance is equal to parallel combination of these two, RC into RL by RC plus RL. Okay, parallel combination of these two we have to take, that is a 6 kilo into 3 kilo by 6 kilo plus 3 kilo, then which gives you how much here? 2 kilo ohms. This is also one of the simple question. This type of analysis is comes under hybrid hybrid model of the CE amplifier. There we have to write equivalent model, right? So within that equivalent model, output resistance is the combination of parallel combination of RC and RL it gives here, right? So from that I wrote this R naught, that is 2 kilo ohms. This is also called as output AC resistance, output AC impedance, right? So how much it is? 2 kilo ohms. So option 4 correct. Please take this. Yeah, this one is the same question. It comes under class power amplifier. Okay, from the power amplifier we got 2 questions here, right? So direct in class A power amplifier efficiency is less than the 50%, maximum 50%, and expected value is 25% to 50%. So according to the given statement, so we can take 50%. And class AB power amplifier greater than the 50%, and class B exactly 78.5%. Just now we have discussed in class C 100%. So this is direct question, one of the simple question and direct question. So directly we can select now 1A, 2B, 3C and 4D. So according to the given question, option 3 correct, right? Yeah, question number 113. Yeah, this is comes under operational amplifier question, right? So first of all, go through the operational amplifier. Here the input voltage is given, right, and input voltage is connected to which terminal? Negative terminal, right, and positive terminal is grounded. So this is comes under inverting amplifier. For inverting amplifier, what is the gain of the amplifier? Minus RF by R1, right? So this is acts as feedback resistance and this one acts as input resistance R1. So if you simplify that, it gives the 80K by 8K. So that value is 10. So I am not writing negative because negative explains the phase shift here, right? So what is the gain of the amplifier here? 10. And according to the given question, it clearly mentioned the op amp has unity gain bandwidth. So gain bandwidth, the general equation is gain into bandwidth. Okay, product of the gain and bandwidth is called gain bandwidth. So unity gain bandwidth is how much here? 6 megahertz is clearly mentioned. Then we want here bandwidth, because we want here bandwidth of the circuit. So bandwidth is equal to, we can write now 6 mega by gain of the amplifier. So gain of the amplifier is how much here? 10, right? Then substitute that part now. Yeah, so if you substitute that, bandwidth is 6 into 10 to the power of 6 by here it gives the 10, right? So gain of this one is 10. So we can write now 6 into 10 to the power of 5. But options are given in terms of kilo. So write the kilo now. 600 into 10 to the power of 3, that is a 600 kilohertz, right? So according to the given question, we can write the answer 600 kilohertz. So option 2 correct, right? Please take this. Yeah, another simple question. A wide band pass filter has a lower cutoff frequency and higher cutoff frequency than F0. See, the general characteristics of the wide band pass filter should be like this with respect to frequency. At low frequency it does not allows, high frequency signals it does not allows, but middle frequency signals it allows, right? So we can draw like this. This is the general expected bandwidth. Then this is the maximum value. Then lower cutoff frequency, higher cutoff frequency, we have to take 1 by root 2 times of the maximum value, right? So this explains the lower cutoff frequency and this explains the higher cutoff frequency. Then we want resonant frequency. Resonant frequency is also called as center frequency. One standard formula is there. Resonant frequency is equal to square root of FL into FH. Okay, this is one of the standard formula which is used to find the resonant frequency. Lower cutoff frequency is given 50, right? Substitute that part now. 50 into higher cutoff frequency is given 5 kilo, right? That parallel I am writing here root 5 into 5 25 into 10 to the power of 4 I am writing now, because kilo into here one more 0 is there, so 10 to the power of 4, root 25 is 5 and square root of 10 to the power of 4 is 10 to the power of 2, so finally we can write the answer 500 hertz, right? So resonant frequency or center frequency of the given circuit is how much here? 500 hertz. So according to the given question, option 2 correct. Please take this. Yeah, this is also one of the repeated question. Already we have discussed this question in gunshot bits, right? So fixed bias circuit. For a fixed bias circuit, the stability factor is how much? 1 plus beta. Right, stability factor of the fixed bias circuit is 1 plus beta. That is the fixed formula, right? So option 3 correct. Please take this.